absolute values. You can go crazy with absolute values because it depends on what you're absolute valuing, if you like. So we start with the first type. If we're going to go y equals the absolute value of function x, so this will end up with some sort of symmetry. Well, not so much symmetry, but reflection in the x-axis. So basically we're saying whatever's below the x-axis gets reflected up. So here's good old random curve again. If we were to draw y equals absolute value of function x, then whatever's below, that disappears because the y value has to end up being positive because you're saying the absolute value. But it'll reflect up, so it bounces up. So there's y equals the absolute value of function x on our random curve. Whereas when it's function absolute value of x, this one will have symmetry in the y-axis. Because now the left-hand side will disappear. Because you can't substitute in a negative number, because before you're substituting it into the function, you're substituting it into absolute value of x. So whenever you substitute in -2, you'll get the same as when you substitute in 2. Whenever you substitute in -5, you get the same as when you substitute in 5. So you end up with whatever's on the right-hand side gets reflected over. So with our random curve, anything on the left disappears, and then the right-hand side reflects over. So that will be function absolute value x. Okay. Absolute value of y is equal to function x. So this is now saying that function x can equal both positive and negative numbers. Because we're going to say it equals the absolute value of the y value. We end up with symmetry in the x-axis. We reflect the part of the original function, which was positive, in the x-axis. Let's have a look at random graph. Here it is. Again, that bit disappears, but we get that instead. You see? So that would be absolute value of y, because what we're saying is the y values can be both positive and negative, but the function x value will only give you the positive results. All right, what about if we did both? Absolute value of y is function absolute value of x. Well, the way I think of these ones is, if I just did function absolute value of x first, and then did the third one, so it's sort of a combination, we're going to get symmetry in both x and y, if you like. Because what will end up happening is just the first quadrant now will end up reflecting into all 4 quadrants. So here, all of that goes away, and we'll end up with that. We'll end up with that. So the first quadrant ends up in all 4 quadrants for this one. Okay. Oh, let's keep going. Y equals the absolute value of function absolute value x. So, well, again, this will be a combination of the second one and the first one. So we'll have symmetry in the y-axis, but we'll have reflection in the x-axis. So basically reflect the part of function x which is positive in the y-axis, and then reflect the result. Let's have a look at it. There's our original graph. So first of all, I just do function absolute value of x. That's what we saw for that one. But then I'm going to do the absolute value of that. So whatever's below reflects above. End up with that one. Alright, what about absolute value of y is equal to absolute value of function x? So this one would be a combination of, what ones have we got? The first one and the third one. So this will have symmetry in the x-axis and reflection in the x-axis as well. So here we go. First of all, there's y equals absolute value of function x, and then absolute value of y equals absolute function x. That now reflects through. So we get some fantastic different graphs. All right, I could keep going all day with these. It's so much fun. That gives a bit of an idea.